If you've got a question, the voices of resin are here. Oh, PlastChicks.
PlastChicks is an SPE sponsored podcast.
Hi.
It sure is. Hello. How are you, Lynzie?
You know, I am doing great. The sun's not shining, but we can pretend for the sake of today the sun is shining. My attitude is shining like the sun should be.
You have an amazing, is it French braid going on?
Yeah, so my mom did these because my mommy does my hair sometimes. And I slept in it because I was like, I'm not taking these out before our call because she does them good. She's got a good technique down.
That's impressive. It's still tight, like for having
it hurts when she does it, but you know, pain is beauty.
All your wrinkles are gone. Your hair.
I look like I have a face. Maybe that's why I'm in such a good mood. I look 10 years younger today.
10 years younger because mom did the hair.
Yes, mom did my hair. Love that for me.
Well, I am Mercedes Landazuri.
And I'm Lynzie Nebel.
And with our powers combined, we are PlastChicks, the voices of resin.
We sure are. And you know what? You can listen to our podcast the first Friday of every month, anywhere you want to get a podcast. And if you want to see me looking 10 years younger, you can check out the YouTube right after. And you'll be like, oh my gosh, 10 years younger, for sure.
So that's like a for SPE YouTube channel.
Sure is.
Mm-hmm. And today with us, we're not just alone in we are alone in our home offices, but on the line with us, probably shouldn't delay it any longer because, hey, it's noon for me in Central Time, but I hear that it's midnight where our guest today is. But we'd like to introduce Tuan TranPham, who is President of Americas and Asia Pacific at Anisoprint. Tuan, thank you so much for joining us this evening.
Thank you so much for having me. It's a pleasure to be here.
Well, so we have so much to talk to you about today. We were just talking about how there's like 50 questions we want to ask you. So I'm going to jump right in. And let's start way at the beginning. Can you walk us through some of your early experiences from refugee camp to Denmark, eventually the US? Rumor is you live in the New England area. And how is that like trajectory shaped how you see manufacturing? You know, you're very heavily involved in the additive manufacturing space. And, you know, what perspectives does that very global influence bring to the table?
That is a very big question.
Start off big.
So the short version is, I was born in Vietnam, and I left Vietnam in '79. I'm a boat refugee. I live in the UN refugee camp. Grew up in Copenhagen, Denmark for 23 years. Always wanted to go to America because that's what we were supposed to go, but we didn't because everybody wanted to go. But with a little bit detour, growing up amongst the Vikings, the Great Danes and blonde, tall, and then this little Asian dude for 23 years. I finally got away to, actually people don't know this bit, but before 3D printing, I was in semiconductor. And the company I worked for got acquired by Intel in 2000 for 1.25 billion, and that was my ticket to be transferred to the US. So I live in Boston most of my American life. I recently moved to New Hampshire because my son got himself into a nice high school in Exeter. So with getting to 3D printing, it's kind of a little bit embarrassed. I'm a trained business. I have a business engineering degree, but I never knew about 3D printing when I studied. So through now my wife, through a friend of a friend at a reunion party of Boston University, I stumbled upon 3D printing. So I always call 3D printing my accidental passion because I never knew. But once I discovered it and was invited for lunch, and I saw the ball bearing with glue and powder coming out of this Indiana Jones excavation, I was blown away. This is 2003. Like, I gotta be a part of this. This is 2003, and this is an MIT spinoff. And in 5 years, everybody will be using 3D printing. It took a little bit longer than that.
Yeah.
But
And you,
to answer you, go ahead.
oh no, I was gonna say you studied in the UK too. What did I was I am I remembering correctly that you were part of the Erasmus program? So you got to live in
Yeah.
different parts of Europe as well through that, huh? Well, the EU back before Brexit, I guess.
Yes, so I always thought that the world should be the playground. So any chance I get, I try to travel. So to answer your question, doing my engineering degree, business engineering, they call it export engineering because Denmark is a tiny country. All they do is make up something and then they export it, whether it's being Lego, B&O, or Carlsberg beer. It's all about export. But I was lucky during my degree to apply for the Erasmus Student Exchange Program. So I went to Manchester, studied the University of Salford, and actually that was when this is in '96, and this is actually when I was introduced to email. And nobody used email back at the Copenhagen, the Danish Technical University. So I was like, by traveling, you get exposed to new culture, but a high tech, and we didn't even use emails in Denmark. So I did that, and during my career, I was on consignment, lived in Japan for 2 months on consignment for Intel, training the Japanese sales team of Intel. Um, so travel has always been part of what I enjoy, and I've I can say that I've visited both the new seven wonders of the world and also the old seven wonders of the world. So those are a few perks of traveling, selling 3D printers for 22 years.
Amazing, amazing. So you've worked with a few different 3D printing manufacturers over the years. How has your thinking evolved from company one from the first company that you were with to where you are today with Anisoprint? Can you tell us a little bit about what sets Anisoprint apart?
Sure. So during the last 22 years, the world was very simple. The industry was very simple 22 years ago. There were very few players. Actually, it was only Stratasys, Dimension, BST, and SST, and Z Corp. There was nobody else below 100,000. Today, we have hundreds and hundreds of manufacturers. But the first decade, there was a lot of plastic that dominated because the industry is like now 40 years old, but it was all about prototyping, concept modeling, good enough, and a lot of reiteration. And full color was awesome to make a new Adidas shoe or Nike shoe because quick concept and before you make the mold. But then you start to see a lot of jigs and fixtures, and then you do a lot of rapid tooling. But the industry hasn't really grown into rapid prototyping. So to answer your question, how the industry has evolved has been from good enough prototyping, quick and dirty, to stronger part for tooling, and now trying to move into mass production. And this is where we're starting to see weirdly that how come metal 3D printing is so hype? How come we always talk about metal 3D printing? Well, the most dominant technology for metal 3D printing is later part of bed fusion, but essentially is high precision micro welding, and is heavily relying on traditional manufacturing like MIM and the supply chain of powder. So using the same powder, you get very good quality. The challenge I see for the polymer, which is the focus of this podcast in the polymer world, is that most of the things we use is in polymer, right? Look around you, it's just the planes, the car, it's all sheet metal and metal, but most things are plastics. But the challenge the 3D printing industry has with growth is we want to do mass production. We're 8 billion people on this planet, so doing more consumer products, there's a lot of consumption. But here's the chicken and egg. If you want to have good product made additively, you need the material, the resin that can produce in the high quality. But who's making those? You have these OEMs, hardware guys who's very good at making hardware, but they are not chemists. They're not BSF. They don't make the resin. So in a way, you can say the industry has been borrowing using leftover from traditional manufacturer of plastic. Hey, can you use this for additive? But it wasn't designed for additive. And the additive world don't have the money or the supply chain or the skill set or PhD or chemist to actually produce the resin. So this is where we saw a leapfrog and hype of metal 3D printing, where we really, if we had the right resin with the right recipe, we could do like, why are we not seeing pickable paddle being 3D printed? They are superior, they're lighter, they're stronger, but they won't, they're not good enough to survive 1,000 game. So the quality of the resin is the weakness, and also the resin, the material is what unlocks application, and the application is what's driving the revenue and the money. Did I kind of answer your question?
Well, yeah. So getting to with Anisoprint, I would imagine because anisotropic. So this is a stronger material in certain orientations.
Yes. So as for Anisoprint, I joined back in November. I was in composite before when I was a few jobs back. I was with Avivo. We were doing continuous carbon fiber, thermoplastic, filament, and we were melting it using an ABB 6-axis robot arm and a rotating table. So we could build a unibody bike frame in one go with no seat tube for the first time in human history. But so I always feel like composite is the neglected material. What I mean by that is everybody know about plastic, polymer, and then now a lot of in the additive world, metal. Everybody's talking about metal, but in between there's actually composite. And then I wondered why is it that not why are there not more people using composite? And so for composite, you really for additive, you have like chopped fiber and continuous fiber, the long fiber. And one of the leading companies for continuous has been Markforged. And given their business model over the last many years, their filament is very expensive, the machines is very expensive, it's a closed system. And so a lot of people would like to try to do stronger part, lighter part. Think of anything that is airborne. Think of drones. Drones is exploding right now, and anything that's airborne, properly electric battery, it needs to be light and strong. So composite could have a bigger play in the additive world if it was more affordable. And I have a few. I've been working on that for 6 months, and there should be something exciting coming out soon.
Ooh, this exclusive. You've heard it first here on PlastChicks.
It's
6 months from
true.
now.
Hopefully earlier than that. Hopefully late summer, you might see something on Kickstarter. Now you even know more than most people on the planet.
Man.
Oh, nice.
Hang on. When are we going live with this show?
Yeah, it's not going to be until like November or something, so we should be good.
I think
Okay, we should be good.
October, something, yeah.
Fall.
Okay,
Fall
then I can reveal a lot more.
Oh, okay. So going along with that, you've been called the most followed person in 3D printing. And looking at your, LinkedIn alone, you have like 40, I think I wrote here in my notes 43,000 followers, but I think it's actually like 44 when I checked on LinkedIn yesterday. So like you're just continually growing. How do you keep and like constantly provide a value to that many followers? Because that's a big deal. That's significantly more than anyone else I know in this space.
Yeah, absolutely.
Well, before I answer that question, I think I'll start with the beginning. I start doing the sharing out of a necessity. Remember in the early 2000s when there was a hype and everybody was 3D printing in the home and the stock price was crazy and everybody went crazy and all that, and the media starting to write crazy, silly stuff about 3D printing. It's not true that you can print anything. So it's actually was that as a member of the community, I kind of like we need to educate the media as well, because if they misinform people, they're going to be disappointed because this is not true. So I became like I volunteered myself to share what I know, and I was new in metal 3D printing as well. So I decided that I will share what I know, and hopefully it will help somebody, and I start to educate people, inspire people, and share people what I know. And I found that LinkedIn community was very supportive. You're always afraid of trolls or being shut down, but the additive community has been very supportive, helping each other. Here's a dirty secret that all students should know, that I wish I was told, is in life, you get much more by giving than taking. What do I mean by that? By sharing whatever I know, right or wrong, but mostly right, because I'm doing it. I'm selling these
Right.
electron beam
Right
machines, and then
intention.
I'm fighting all the laser guys. So I share what I know, powder size, technology. And when you share what you know, actually the comments in the community fill in the blanks and the holes and correction. So your content only get better, but you get credit for putting it out there. And then the community come together. We all learn collectively. So it's kind of like a hardness program online where people learn together. And I think I got a lot of goodwill by. I usually share about 5 posts a day for over 15 years. So this is really the, if you go, it used to be syndicated with Twitter, so it's kind of like the entire industry history transformation. But with the breakup, it's just on LinkedIn. That has been the platform that I've been focusing on. But it's a mixture of what I see that is cool, and because I've seen a lot, what I share is really cool because I haven't seen that for 22 years. So the threshold is different, but I think going back to LinkedIn, if more people, I wish more people would share whatever they know. I don't know much about software, so I wish more people will share about what they know about software for the traditional manufacturing or the additive side. That would definitely complement what I know. But the going back to your question about LinkedIn, well, it's just as easy to click unfollow as follow, just as easy. So to answer your question, having this um, uh, continue to inspire people or educating people or involving people and supporting people, I think people don't follow companies. People follow people. And when they
Mhm.
follow people, I hope the people follow me is because I love 3D printing.
Mhm.
It's not a job, it's a passion, and I'm still loving it. And I think people follow me because if they like 3D printing, they like what I share, and that just continue to grow. So I grow about 1,000 every 6-7 weeks.
I believe
Wow.
that. Yeah, and I think the authenticity that you have in your posts, like you're saying, like I love 3D printing. I think that passion comes across so much more relatable to people that are like, okay, do I want to like dip my toes in this 3D printing, this additive manufacturing world? And they see someone like you posting. I think it comes across a lot more exciting and engaging than someone being like, please follow us here at this boring company doing something that we do every day with no like enthusiasm, no excitement. So I love your posts. I did notice the other day that I wasn't getting them as much, and I was like, wait a minute. I'm like, I'm pretty sure I was already following him. So I did change that. I did make sure that you were on my like always follow or whatever it is. But I do love your posts. They are very they really come across with the same like excitement like I feel about injection molding, which is older and dustier if we're going to be honest.
Speaking of older and dustier, no, but Tuan, I like how you say that that you started out of necessity, right? It was you felt that the media was getting 3D printing wrong, and it was like, all right, we need to make an effort, like to educate. So talking about the traditional plastics community, I mean, I've only been in the plastics industry, what, 9, almost 10 years. And you know, 3D printing, additive manufacturing is a newer process. And so I've seen like a little bit of pushback from some parts of the industry. What do you think we still need to educate the traditional plastics community about 3D printing? What are some misconceptions you've found from within the traditional plastics community about additive manufacturing?
Excellent question. And actually, this is the reason why a year ago I decided to join SPE AM chapter, trying to connect the SPE community. There's so many chapters, different area of focus, but within the SPE, but also with the traditional manufacturing and AM. And while the board is AM, so we had the SPE and then the rest of the traditional manufacturing. I think my take on it is that traditional manufacturing kind of was oversold by the media and the industry a decade ago. So a lot of people tried, they got excited. I'm talking about traditional plastics guy trying to, well, these guys are used to high quality, high volume plastic injection molding and all that. And these guys says 3D printing can do that too. And that is crap. 3D printing cannot do that. It can do short production one. It can do some at a certain quality. So I think the industry did itself a disfavor by the first impression was hype, and people are like much more cautious. Remember when you said traditional? This is people who've been doing it for decades, and
Yeah.
just the resistance to the reluctance to even try something new, whether it's being 3D printing or not, is a challenge. So it's really about our mindset, and I think the only way to show them or inspire them or to change them is by educating them and inspiring them. That's why I became part of SP, because just telling them here's new technology, here's a new printer. People 3D printing has been okay selling, inventing hardware, just selling them. But to answer your question, what we need to do in the industry is actually go further and look for application. This is actually how we solve it. This is how it complements plastic injection molding. So by being more educating, more inspiring, I think that's a better way, a softer sell to educate the industry, because I don't think we've done a good job as a AM industry trying to get the rest of the traditional, because it doesn't take much for a 3D printed part to just be knocked on with a hammer and it will break so easily, right? Because it's not strong enough. And while metal is the same powder you've been using for metal injection molding, and therefore when you weld it together, you're gonna get good metal. So it's more forgiving, but really for the industry to grow to a real industry, by Goldman Sachs it's 100 billion. We need the plastics. We need to we cannot ignore it, because metal is still for the rich and privileged, like the aero engine or the titanium implants. But most people, like, we walk around, our clothing, our shoes, what we use around the house, the TV, everything is plastic. And so we have a lot of growing up to do.
Yeah, I, you know, as someone who sits well within the injection molding world, I definitely, I think your approach is right, because I think there's still even a lot of unlearning between, you know, injection molding manufacturers and their customers. I know one of the biggest things is always talking about like that prototype to manufacturing gap, and you know there's a lot of, it's not one-to-one, and there's just so much education that maybe got missed in all the excitement, that I think now we're all starting to go back and be like, all right, let's go back to the middle and actually talk about where this provides the most value. So I do love, I mean, like I said, I am part of the dustier version of manufacturing, but it still could be fun. There's still cool stuff sometimes.
But
So
but to your point, who is doing that education? Not many.
no one formally, yeah, and no one on a
And that,
broad scale.
so in some way, that is one of the hidden need that I see in the market, where I try to
Mhm.
chime in. I have a full-time job, but whenever I have time, I share when I find cool stuff or white paper. I try to help with that. But it's going to take a lot more people, a lot more work than that. And the government should get much more involved.
Yeah. Yeah, I think you're right. Like you basically have to learn it on the streets, if you will, right now. Um, and so one of the things we were talking about is there's going to be this convergence between additive manufacturing and CNC machining. Can you tell us a little bit about that? Tell us some of what excites you about that?
Yeah, so subtractive and additive for the early days was more like is it going to be competition? But reality is more complementary than anything, because the truth is most, especially metal 3D printing, will never be net shape. So the more parts that is printed in metal, the more parts that need to be machined, because it's never net shape. It has the roughness of surface finish that is never acceptable. So I think what the industry has done is also that were manufacturers who did hybrids, that when you were doing additively and you were doing subtractive. I think more and more people understand that it's complementary, but more on the casting side has been more open to try additive. But I think the convergence is so. I'm a 3D printing guy, but to my own surprise, I realized like I got to stop hype 3D printing, because the reality is it's just a tool of many tools. And when another thing I wish I learned in school is if you want to leapfrog, when you see the poor countries trying to use high tech like the cell phone and skipping the landline and all that, it's like, why weren't we taught about? Let me ask you, were you taught about the fourth industrial revolution when you went in school? I did
Nope.
it. I had no idea what was coming and what could be coming and how they would converge. And that if I want an exciting career, either I sell Colgate or something that everybody has been doing, or sell something cool that doesn't exist like 3D printing. So I hope that all engineers, I wish any student will look at what could come ahead. And if you look at the World Economic Forum, I send you that chart because that's one of my favorite charts. And of those components, so I want to expand your question a little bit, Lynzie. It's not just the CNC subtractive, but it's automation, it's robotics. You see robots anywhere, everywhere now. You see and read about humanoids everywhere. And so you have all this big data and blockchain and sensors and IoT. When all that comes together, it will not all come together, but a few components, when they come together, this is later one of the other questions you had to me. When you put those components of the many components together, you could create the microfactory of the future. But we get back to that later. But what I'm to answer your question, I think there needs to be a convergence. 3D printing in itself is just a tool. It is not enough. It won't change the world by itself. But together with sensors, automation, process control, machine learning, if we had machine learning 40 years ago when we started 3D printing, and we learned for all the failed prints for any technology, for any material, if we had that data and we fed an AI, LLM, we would have been moving much faster today. But we don't.
Mhm.
We never process that data.
Mm-hmm. Yeah, absolutely. I mean, the convergence is everything, right? I mean, like with the Industrial Revolution that we did learn about in school, how it completely changed the world. I think Lynzie and I are both sitting boldly bifurcated today in pants, thanks to
Let's go.
how much everything changed the world then. But yeah, absolutely. There's a lot of exciting stuff happening in innovation and new technology now. Now, speaking in terms of like trend forecasting, which is very much my domain, you said that you have said that 3D printing will hit its peak around 2032. So what's driving that prediction? I'm curious. And what does the peak look like to you? What does it mean for you?
Yeah. Well, when you read about technology and innovation, the internet, the phone, the plane, for most technologies, it takes about 50 years to mature. Just like any new product, it takes 5 generation revision to get a mature product before you should sell it and not sell it too early. So it used to take 50 years. And the industry is about 38, 40 years, depending on who you're asking. It's at the beginning of when SLA was invented or when it was actually commercialized. But let's say the industry is like 38, 40 years. So the prediction I had was if that is true, it's about 2032, it should peak. But what are the challenges for it to for us to unlock for that to happen? So Goldman Sachs said you have to be 100 billion. Okay, we've been growing. When I joined 22 years ago, we weren't even a billion combined industry, not even a billion. So it's like, well, a side note, how often in most people's career do you get to be the beginning of formation of an entire industry?
Yeah.
And then in recent years, well, it could have died, right? Most technology could have died. So lucky for me, it's still alive. But then in the good years before COVID, it was growing like a billion every year, very
Wow.
steady. But we're about, so we're going 18 billion, 19 billion, 20 billion today, if you read Wallace report, Terry Wallace. So we still have 80 billion to go. So if we look at the challenge to unlock, we need better material. We need faster process because at the end of the day, you need high quality of part, whatever you want to make, but it's really cost per part. So the productivity, the speed, the quality is non-negotiable. Because if it doesn't get the sign off of the PhD, it will never be a product, right? So we have a long way to go. And the only way I see us going is we hear about aerospace, medical tooling, all that, but we are 8 billion people on the planet. Unless we do more consumer product, and we're going to be 9 billion soon, we're going to be 10 billion. Unless we can do additive 3D printed part for whether being polymer or composite, make it much more affordable, much higher quality, lower production rate. If we don't get to production, we will not be a real industry. We will not, it will not peak in 2032. But if we get the right resin, so like if you ask me right now, okay, polymer mass production application, the poster child. We all hear about the Adidas midsole bicarbonate. Well, we've been hearing about it for 7 years. What else is new? Ellen Lee was the beta tester on that shoe of carbon, but she was one of the early resin 3D printing testers of the carbon machine. But if you ask me right now, can I name a dozen application, polymer application that is consumer product in high volume meaning, let's be nice, say 100,000 unit. Reality is we 8 billion people should be millions of units. I can't even name 5. Maybe a lot of them are still under NDA, but it's still a lot of challenges we need to unlock.
It's funny that you mentioned that shoe because actually this month, when we're recording this episode in July, Adidas is releasing their first fully printed 3D sneaker. Not just the sole, which it was previously, but little sneaker release news for you there.
So they're growing up too, right? And the reason why they're the real deal is I found out they actually found the secret ingredients from Japan that is needed to make it high quality. And they kind of locked that down so nobody else can do it. I tried. But so you need the right ingredients to actually do high quality 3D printed resin part.
Now you've spoken about the micro factory of the future. Can you talk a little bit about that? What does that look like? What role do you see it playing in the next decades of production?
So the background for that is a combination of a lot of things, right? You hear about, remember COVID, supply chain disruption. We talk about the political situation about reshoring, getting manufacturing back. We're talking about, so I watch technology, I share news 5 posts a day, and I'm starting to decode that the reason why 3D printing is like CNC 40 years ago when there was few players, no simulation, all G code, still G code today, but it was very basic. 3D printing has a long way to go, but what I was trying to get at, I think I lost my train of thought. Oh, the microfactory. So I start to see a lot more robotics in the last 2-3 years, and myself with Avivo doing continuous composite thermoplastic. You see robotics doing cement 3D printing, doing not 3D printing a house, but the shell, the walls. So we're seeing cement, we're seeing composite, we're seeing pellets. And so when you have all these heads, if you can learn from CNC and have humanoids and have robotics, 6-axis, Google, Fanuc, and have interchangeable tool head just like CNC, you could have, inspired by Divergent, how they are building their micro factory, lights out, no humans involved, all machine learning, AI, automation that can produce anything from a missile to a supercar to whatever you need. I think that's the only way we can move manufacturing back, is to have removing the human factor, the human cost, but also have productivity and automation and have versatility in the materials so that within the same cell, imagine. So I was a little bit inspired because before this job, there was another interesting potential company called McKinney Labs. McKinney Labs is in Los Angeles. They have incremental sheet forming. So they have 2 robots moving and reshaping uh, sheet metals, which is very commonly used in transportation. But they have interchangeable head that can now do scanning and also milling. So if the industry already have heads that can do composite, glass, fiberglass, and metals and all that, what if you just have a machine that could do all of that? Then there's no humans involved. You have machine learning, you have robotics, humanoid. Then that cell can be deployed in the field, in the battlefield, in London, in New York. Just add power. That will change everything. So I think, but once you have microfacture, you can just scale that.
That's really fascinating, because I feel like it's kind of that the word's escaping me right now, but kind of having like a set modular, there we go, setup in and making these little micro factories, or making something along those lines to have that modularity to move to transfer. Like, that's a really, I feel like that's end game for a lot of companies. They just maybe many steps behind, and not even just in the additive manufacturing space. Like, I'm thinking specifically injection molding, I'm thinking specifically in biopharma. Like, there's so many other ways that type of like micro factory like theology, I don't know, I gotta drink more Diet Coke, my words are really
how you can apply it, right? In
Yes.
so many different, yeah.
So kind of on the other end of things, where you're kind of bringing all these things together, you've also mentioned the shift from like actual hardware ownership to cloudification of manufacturing, which that's the first time I think I've ever heard that phrase, which I kind of love it. How big of a game changer is that mindset shift? And, what does that do for small and mid-sized companies, especially?
So this is because I read a lot. And this is how because if I don't read a lot, I don't find the cool stuff to share, right? So one of my favorite books is Who Moved the Cheese, or Who Moved My Cheese? And the trick is you have to pick up all the small steps and then figure out where's the trend going. So you're starting to see in recent years that like other big players like Sora or Freeform or Vulcan Form, these manufacturers start to not sell any equipment. They're just selling you the parts. They have full control. They will never sell any equipment. So they're just selling parts. And also because it, like for plastics, I think there's thousands of manufacturers, plastic 3D printers today. Way too many. So I think over time is the days where, hey, let's have a cool technology. Let's put it into some hardware. Let's ship it. Let's sell it. Let's make some money. And they find out what it can do. It's like you selling a lot of ovens, and they figure out what to bake. Those days are gone. People have tried it, and they've been burned. They were hyped. They were sold to having a 3D printer in every home. Hello, people don't even have an espresso machine in every home or sewing machine in every home. So it's kind of like ridiculous back then when MakerBot said there will be 3D printers in every home. So I think the days are over where going back to the basics. Remember when we had Ginkgos? But it was more when you need a nice resume, nice print. You went to Ginkgos and they could 2D print your stuff. and do all of that. I think that led me to maybe there's need for a ginkgo's 3D printing ginkgos that I don't want to buy a machine. I don't want to operate it. I don't want to be building in a facility that is explosion proof. I just want my pot, whether it's being plastic, composite, or metal. I just want somebody to make it for me, and I want you to make it for me and ship it to me. So it's relating a little bit to the like, the Amazon AWS, you're just buying storage. Do you really know, do you really care where that storage in the cloud is, in Finland or in Turkey? Who's the security guard? Which brand on the server or the rack? Humidity, temperature? Do you care? No, you just want the storage. You don't care about the brand, the location. So I thought, well, maybe the future should be and will be 3D printing in the cloud. So it's like AWS 3D printing cloud, where people have a need and they upload the file what they want. And this correlates with other trends, like you can now, 3D printing was restricted to the privileged engineers who could actually code and using CAD. Well, those days are over. Just like coders are losing a lot of jobs because of AI. Well, the good thing for 3D printing is now we have text, speech, sketch to 3D CAD.
Yeah.
So we're now unleashing the creation of content that could be 3D printed. They will be game changing, because if you think about a silly question like this, do you think we would have sold or consumed as many 2D printers the last few decades if we didn't have Microsoft Office? If we didn't have Excel, Word, and PowerPoint, do you really think we would have printed that much? So I get excited about AI and machine learning, and the content can be democratized. So anybody can, even the kids can just sketch a dinosaur that have articulated arm and tails and upload that file, and the AI will make a solid 3D CAD, hollow it out, connecting joints, everything done for that machine, for that technology, for that material, error-free, first print, go in the cloud. I think that has to be the future, because if other technology, other industries, other sectors can do it, we should learn from other sectors. So it goes back to a little bit of nobody has really talked about this, but I've been trying to sell 3D printers for 22 years. I've sold most technologies for a lot of OEMs, but nobody really asks, what does the customer really want? So I start to put together the bill of rights. What are they entitled to? What are their rights? And at the end of the day, it goes back to really two things. They want to make a part, whatever material it is, but the quality is non-negotiable. Give me a part, this pen. If the quality of that part is not good enough, that's in a discussion, because it can never be a product. But if you can make this quality in metal or whatever my requirement or my prerequisite, you can do that quality. Now let's talk. Now it's cost per part. It's all about money. The world's driven by it. If it's not, this is where additive might grow and continue to grow to complement, but traditional manufacturing will always stay, because in super high volume plastic injection molding, nobody's going to replace that ever. Not in my lifetime. I want to put a disclaimer a little bit, but I think that once that's done, they don't care which 3D printer, which brand, which technology. This is a new volumetric. I could do it super fast with light, all that. I don't care. Is the quality good enough? Otherwise, you're out. Too many manufacturers invented something and have a piece of hardware, but not necessarily making the quality that is required. But after that, cost per part, I don't care where the machine is, but I kind of want the facility that this 3D ginkgos or 3D printing in the cloud, these microfactures, all the technology, all the material is in my home country, so I avoid tariff. Tariff is a big topic recently. So having domestic across the street, locally, when you have microfacturers that can do all the technology and all the material, now it's scalable. It's a micro factory. Demand is growing bigger in UK. You scale it bigger in UK. So I think that has to be the future, just like Amazon AWS. But now we're just making physical products.
So you said, okay, so democratizing 3D printing with these like new the cloud, right? And are those, you mentioned the Bill of Rights in passing, the Bill of Rights for industrial 3D printing customers. So you mentioned quality, cost per part, and localization. Anything else that you would include in that Bill of Rights for 3D printing customers?
I think those are the main one because, and this is what a lot of people don't get. When you go to a trade show, you see hundreds of manufacturers. A lot of them are just incremental, a little bit better, but not really that different. So this is why there needs to be a massive cleanup and regrouping. But the Bill of Rights, it is if everybody can have an idea and have a part made, not in China, but locally, anywhere, any material, but high quality and cost per part that is competitive to traditional manufacturing. I think this is what we need to unlock, and this correlates to the 100 billion we need to get at. Otherwise, we won't be in 2032, which is not far away.
No,
No, it'll sneak up on us.
yeah.
Well, we're running low on time, but I do want to ask you this question because I think your insight's pretty critical here. You've been in this industry a while. You've seen a lot of hype cycles. How do you separate the short-term buzz from what the real long-term innovation or long-term value is going to be? Because I know some people can really hop in the industry with some buzzy, fun words that really kind of amount to nothing versus the stuff that maybe doesn't get as much hype in the beginning, but is probably going to be the more valuable long-term things that you really stick around.
That is a big question too. I would say the short answer is, are they solving a real but big problem? So there's so many startups. Most startups die, but are you solving a real problem? So for 3D printing, for polymer, like carbon, they actually they solve the quality problem. It's really it's amazing that the 3D printed midsole and now whole sneakers or a shoe can be made that is durable and actually lasting. So that is mind blowing. So I think you need to solve a real problem, but cost effectively. So a lot of, in some way, no wonder people are skeptical, right? There's so many startups. In the early days, there were a lot of silly money. There were like $2 billion US dollar coming in 21, 22, 23. And you said 3D printing, you got money. Today, you said 3D printing, you don't get any money. Actually, they've run away. So if you have a real idea and real problem, so it has to be more niche, more application focused. So another way of saying this, any 3D printing company who invented a new machine and they're selling the machine, run away because they're not solving anything. But any company who are actually solving a dentistry dental problem with a resin that is superior, that can only be done this way and is much more cost effective, I will give them money. So, but if it's just solving a little problem, it's not going to change the world. They might not even get the funding. So another way of putting it is if they're solving a real problem, is solving a big problem if they have the right team to execute that, and are they being authentic with real marketing or just hyping it for the next round? If you do it the right way, I think there is room. But another way of saying this is consolidation is happening and it's needed. But actually, if you look at the numbers, like Nanola mentioned, buying Mark Ford and Desktop Metal, from a revenue contribution, is actually insignificant as a whole industry, that consolidation. So that means there's still a lot of companies that should die. If you're not solving a problem, you're not getting money. There's a reason for why you can't get money. So and the other side of that story is the companies who are getting money during these last year and this year, they're only getting money because they're actually solving something. And that's one of the reasons why I joined Anisoprint, because I want to make the most affordable, user-friendly, desktop-friendly continuous carbon fiber in the world that it has never seen before. Less than $3,000.
Amazing. Well, Tuan TranPham, thank you so much for joining us on the podcast today. It's been a real pleasure. We've learned a lot.
Thank you
Thanks
so
for
much.
having me.
If you've got a question, the voices of resin are here. Oh, PlastChicks.
PlastChicks is an SPE sponsored podcast.